power consumed is twice because I have two single-ended amplifiers to achieve the same noise figure. So power consumed is high, but noise figure is going to have very decent number that is going to make this differential a potential candidate for the design of low noise amplifiers. And even the dynamic range is also going to increase even though the noise figure remains constant. So what the for biasing, what biasing circuits I'm going to use? I'm going to use the different supply voltages at the gate side and source side, and the gamma and delta value what I choose for the MOSFET. All these are going to determine the noise performance of a differential LNA. So one of the possible methods to achieve the desired results is shown in the figure. You can see this is the final diagram of differential LNA. It is a little bit complicated, but you are having so many components to ensure that the noise performance is also achieved, the necessary amplification is also taken place, the common mode signal is also cancelled, and all benefits are going to be completely achieved in your differential LNA. So we have M1 and M4 are the core transistors. Where is M1 and M4? You can see here. M1 and M4 are the core. M4 are the core transistors for your LNA. The output of the first stage is AC coupled to M7 and M8. So first stage I take output from M7 and V2 is going to be output from M8. Okay. And to save power, the current through second stage is reused to supply the four core transistors. I'm going to use current mirror. So current flowing through one transistor is effectively coupled to all the other transistors, so that I need not separately use biasing circuits for producing current in those transistors. So to keep all transistors in saturation with the low supply voltage, you have a common feedback loop that sets the drain voltage of a fraction of VGS1. So when you want the transistors to provide maximum amplification, they have to work in saturation. So that is done by a loop which will set the value of M1 and M2, which is equal to a fraction of VGS1. M9 guarantees startup of biasing loop by providing default gate voltage for cascading transistors. So M9 is going to kick off the amplification process, and M9 is here. M8, M9 is here. So this is going to kick off the starting of the differential LNA. Finally, because of the modest performance required of op-amp, negligible bias, low bias currents may be used there. So this is the differential LNA structure what we have seen. We have to understand this basic circuit, and you can explain the operation of the differential LNA, and you can say how it is going to effectively reduce the noise and amplify signals at high frequencies.